So far we have created a rule engine, but it is a static rule engine. It has a static rules. There is no extensibility for this rule engine. So how can you make it is extensibility? What I mean is here the rules are hard-coded and the data type is hard-coded and the processing is hard-coded. So how can you make it much more flexible? So whoever using the rule engine can make use of it. So what I mean is adding the rules to the rule engine, and once rule is validated, how to capture the values or how to use it, how to use the processed value. So let's refactor the code. I'm taking out all rules from here. So as it is a default constructor, I can take the default constructor. So all the rules will be added as part of the application itself. So now I'm creating a rule, and here is the one. I'm going to use the rule, and I will be adding all the rules to the rules one. So now exactly the same, there is no difference. The only extensibility that we got is we can add the rules as many as we want. So when we execute it, it's the same result. There won't be any change. This is supporting long primitive data type, and I want to change it to the long wrapper value, or I want to use the double in case we need to use double or big decimal or any other data type. So how can we do this one? So in that case, generics will help us to achieve such functionality. Let's start with rule. The rule can take input. So the input is t, and it is returning same data type. So now it is good. Either we can use a simple t, by default it extends the object, or I can put the limitations or the boundaries, what kind of data types that needs to be used. In this case, this rule engine, particularly for the number calculations or the any other number related one, so I will be saying that it has to be the child of number. So the number is abstract class, and it has decimal. All kind of numbers will be supported: double, long, big decimal, big integer, everything. So now the rule has been made. We have to pass it. In this case, the rules are being created for double. That's what we're planning for it. So let's use the double. So as we used here, so all the logic needs to be changed to have a double. So here, instead of returning 0, we will be returning double of 0. So least rule has been corrected, and let's look at the max rule. Now let's see this, the rule engine. In the rule engine, we need to process it. So even in the rule engine, we need to take only the numbers. So I'm changing the entire rule engine also as a generic. So I'm asking here also exactly the same. It's supposed to be extending the number, and I'll be passing the same to a rule engine here also. So the data types are being captured, and here we need to change the logic. So here the amount which we are taking is a double. So here also I'm saying t. So instead of the amount, I will be saying data. So let's clean up some bit. So we are not going to capture anything here. So we will be just processing them. That's all. Now all the logic is as is there, and least discount is modified, max discount is modified, and the third rule has lambda function which is taking double value, which is nothing but the number, and it is working as expected. So when we run the rules, it will be processing and we'll be getting it, but we lose the functionality, some functionality of what kind of value that we got it, right? So what I can do is I can capture it, saying that RAT data, and I can print it. Rule return data, I'm saying it, and I will be printing it. Anyway, toString will be implemented, so toString will be called. Now we have added system out as well. Now let's correct our rule engine. As part of the rule engine, we are capturing doubles. So let's pass it, and here also we need to change the input value to desired data type. So I have changed it, and let's rerun the application. And we got exactly the same. So we got the rule return data is perfectly fine and discounts are being printed. All we need to now we need to sum it up. Now I would like to capture each and every data into a list so we can process as we need or as per our customer. So in order to do that, I need to take it. Yeah, here one more thing, and I need to return here the double value. And now let's capture everything into a list, which is a double, and here we call it as a discount list, array list, and here a second parameter where I can add all the return values or the discount values into my own list. How can I do it? I need to pass in my own custom. So in this case, I want to add to a list. Maybe I would like to change the logic to maybe some other reason. So in that case, what we need to do is we need to pass another parameter. Let's take consumer, and of the data type, our own data type, and we'll call it as a consumer function. After rule has written it, we are going to call consumer function with our return data. So now we need to pass a second argument. So here I'm passing it. For now, just print it before we add it. So this is on the bill app. So let's call it as bill app discount, and I'm adding whatever the input value. So here it is AWT's value, and after that I'm going to add it to a discount list to a double. Now rerun the application. Now if you observe, all the rules has been called, and each and every place the amounts has been taken care, and our consumer function also being called after each rule processed. So in this case, I'm adding everything to a list. So this is good, and I don't want to print here, so remove the system out, and I don't want to print here as well. Let's take it out every place, all the system outs, so it will be clean output. Now all the discounts has been added to a discount list. All we need to do is we need to calculate it. So how can we calculate? Simple. Loop use streams to sum up all the doubles. So how can we do that? So I'm going to say discount list stream and then map to double. So here we need to call double value and then sum it up. And this is a total discount. Now print the total discount. Now we can optimize a little bit because here we are adding just a list, so we can avoid this parenthesis. And as it's a single method, we can call directly the function also. So I can do is much more simpler. So add it as double. So as we are having only single parameter, this is also easier. Let's reformat. Now the code looks very simple and it is fully customized. So when I rerun the application, I got the total discount 850 as we thought. So let's change it. Let's change it as we are using a double. So let's make it a little more interesting. So here I'm going to say 15,050 instead of the 15,000. So now we will get some decimals because we used the double value. So we'll get some decimals. We see we got 852.5. Earlier it was 850. Now it got 25. That is the whole purpose of adding the generics, right? So where we take the double value and we process it as we discussed. And let's print all the discounts as well. So for that I'm using a peak function, and in the peak function I'm calling system out. So as part of the system out I'm calling discount. Let's reform it and rerun it. So now all the discounts has been printed as well. What are the discounts that has been processed and total sum as well. Now our rule engine looks much more better than earlier. In this way, you can create your own rule engine much more easier and much more flexible and extensible as well. What else can be done? Now we are running each and every rule in this scenario to be processed irrespective of the value. So what we can do is we can stop the rules after matching any one of them, or we can add much more complexity into the rules, saying that when rule is to be run, whether it's enabled or not, once the rule is evaluated, what function to be called. Like that, we can make much more complex framework for the rule engine. So for now, as it's a simple rule engine, that's what our aim is for. So we prepared a simple rule engine which we have the complete control. Now let's refactor the code not to have these many. Which is least discount and maximum discount rules into as anonymous classes here using the lambda function. So now we don't need any of these classes, so take it out. So now our code is very simple. So all we need is one rule and the rule engine. We added the rules dynamically. So now the code looks much more simple. Let's run one more time. Finally, it's working as expected. Thank you.